Hello and welcome to Skills and Automation. My name is Ash and today we're going to look at how to identify what's changed between two versions of the same data set. So we have a before and an after version of the same data set, and we want to isolate any changes that have been made and any new records that have been added and any records that may have been deleted. And at the end, I will do a small tweak in the code that will make it completely dynamic. That is, this technique will work on any data set. So do stay tuned for that. We're going to work on a very real and important business problem. This data here is the item master data, where we have row attributes for each product. In this worksheet, which is called previous, we have the previous version or the older version of the data. And in this sheet, which is called current, we have a current version of the same data. Now, as per any lookup logic in Excel, we will have a column or a group of columns with unique values, which we will use to look up data from one sheet against the other. In this case, that column is the product code, which has unique values. Our macro logic will search for each product code from the current sheet within the column of the product codes in the previous worksheet. And when a match is found, the macro will compare each field in the previous sheet versus the same field in the current worksheet. The business problem that we have here is that we want to check what's changed. For example, in one of my previous companies, we used to run similar audit checks on business data. We had rules for item master data creation where users had to get the right approvals before changing anything. So periodically we would run such a before and after check, determine what's changed, select a sample of changes, get the employee name from the user log, and email that employee asking them to show proof of approvals. So here I've highlighted what's changed in different colors. These colors don't affect the macro. It's just for us to visibly track the changes. So in this previous worksheet, this red line has been deleted. So we can't see this product code in the current worksheet. The value in the cells with the yellow background color have been changed. And coming to the current worksheet, these green lines have been newly added. Once we run the macro, the results will be shown here in the change, new and deleted worksheets. So let's go to our macro, Alt F11. Let's run the macro, and that's run. Going back to Excel, let's come to the change worksheet. We can see the product code which has changed, what field or column header has been changed, what was the previous value, and what the current value is now. Coming to the new worksheet, we have a list of product codes which have been newly added. And coming to the deleted worksheet, we have the product code which has been deleted. And before we move on, I want to mention that this code is not restricted to this data set. Let's say this new data of average grades for different students. A teacher perhaps wants to track the student's progress after each assignment or semester. We are going to use a slightly modified version of the same code. So on top here, we will mention the column that we're going to run the check on. That is our lookup column, which is in column 3, which is the student IDs. And there will be no change to the rest of the code. Let's run this macro and let's head over to our results. The change worksheet gives us the values that have changed. We have the ID of the student who has been newly added. And in the deleted worksheet, we have the student ID who's probably no longer taking the course. Or in other words, has been deleted from our data set. We will be designing the specific modification in the dynamic code section of this video. So do watch out for that. We will make a few assumptions regarding the scenario with the intention of just focusing on the code where we do our comparisons. There will be no error handling of any kind. For example, I will suggest that you check that the headers match before you compare the two data sets, but we won't be doing that here. The column headers in both data sets need to be in the same sequence. If they aren't, the macro will not work. But this is a safe assumption since we are probably pulling this data from the same data source just in different points of time. And lastly, these comparisons are best suited for SQL, and we can use SQL within VBA, but I'm going to leave that out in this video. Main reason is to control the length of this video, and also SQL through VBA would not be as dynamic as the code we are building here. If we want to run this check on a different data set, the effort to change the code in SQL would be far greater than what we are about to do. So we will leave SQL out for now. We will build the code in 4 sections. In each section, we will be building the code based on the previous section. the first section is where we will build it using brute force. Here, we will loop over the item IDs in the current sheet, and for each item ID, we will create an inner loop to loop over the item IDs in the previous sheet to find a match. Now this inner loop is inefficient as it will get more time consuming as the size of the data gets larger. However, this is the easiest to understand for beginners, so we will use this as a starting point. In the second section, we will replace the inner loop with the find method. So we will loop over the item IDs in the current sheet, and for each item ID, we will directly search for that item ID in the previous worksheet using the Range.Find method. This is much faster than creating the inner loop. In the third section, we will be using dictionaries instead of Range.Find. For this, we will loop over the previous worksheet and load all the items with their row positions into a dictionary. Then, we will loop over the item IDs in the current sheet, and for each item ID, we will grab the row position of that item ID in the previous worksheet from the dictionary and then jump to that row in the previous worksheet. For smaller data sets, Range.Find is more efficient, but as the data set increases, the dictionary starts becoming much faster. Personally, I prefer to use dictionaries, but I do appreciate that there is a bit of a learning curve there. And in the final section, we will add the modification that makes this code dynamic. So watch out for that. Okay, let's get started. All the code covered here is available on my blog site. So let's head on over to our VBA editor, Alt F11. One thing before we begin, we'll be using worksheet code names to refer to worksheets throughout this video. There are many benefits to doing this. To set the worksheet code name, click on the sheet in the Project Explorer, come down to the properties, and assign your worksheet code name out here. Now, we will create a separate sub-procedure to clean up the new, changed, and deleted worksheets. Let's create a new module for that. Right-click in the Project Explorer, insert module, give this module a name. Let's create a sub. So we're going to clear contents in each of these change, new, and deleted worksheets. We are basically clearing any data that might be there from a previous run of the macro. So clear contents of the change worksheet, do the same for the new and the deleted worksheets, and we'll assign some column headers. So we'll place this item, change field, previous value, current value in the top rows of the change, new, and deleted worksheet. And that's it. Now let's begin building our main sub-procedure. Create a new module, give the module a name, create a sub. We will start by calling this cleanup worksheet macro. We will need to determine the last row of the current and previous worksheet. And also we need the last column of the current worksheet. Let's declare and assign variables to hold them. To find the last column or the last row, we will determine the current region of each data set and then count the rows or columns in it. For more info on how to do this, check out my video on last row. Link will be below. So to find the last row in the previous worksheet, we will determine the current region of range A1 in the previous worksheet and then count the number of rows in that current region. Finding the last row in the current worksheet and the last column in the current worksheet would be similar. And we'll begin our loop. We will declare some variables that we will be using later on. These are our iteration or counter variables for the loop. And yes, there are going to be 3 loops. That is a loop inside a loop inside another loop. These are some variables to hold the item IDs in both data sets and some variables to hold the last row in the new and change worksheet. Okay, so we're going to loop over the current worksheet data and check for each item ID in the previous worksheet data. If a match is found, we will loop across each column to check if anything has changed. If it has changed, we will note it down in the first available row of the change worksheet. If no match is found, then that means it's a new item. We will then note it down in the first available row of the new worksheet. So here we are comparing the current versus the previous worksheet. We could do the other way around as well. In that case, if no match is found, then that would indicate a deleted line. Okay, so the first row of the current worksheet is just the headers. So we'll start our loop from the second row and close the loop. So our item IDs will be the first column of the current worksheet. Since our final goal is to keep the code dynamic, we'll be referencing cells using cells object instead of range. So cells, the current row is row I and the first column. For each item ID in this brute force technique, we will create an inner loop to loop over each item ID in the previous worksheet until we find a match. So let's create the inner loop. Again, starting from the second row of the previous worksheet through to the last row of the previous worksheet. Close the loop. Let's grab the item ID from the first column of the current row in the previous worksheet. Now, if the two item ID variables match, then we have found a match in the current row of the previous data. Let's close this. Now that we have found a match, we need to check if anything has changed. We will now check across the column length, ignoring the first column, which is the item ID. So suppose we found a match on this 120046 product code. We will check the product description in the previous worksheet against the product description in the current worksheet. Then we'll go on checking the product group versus the product group in the current sheet, and then the unit weight, and so on. Closing this inner loop. We will check if the value in the current column of the current row in the current worksheet matches the value of the current column of the current row in the previous worksheet. This kind of check is only possible because the column headers in both data sets are in the same sequence. And if the values don't match, then so what is the current cell in the current worksheet within this inner loop? It is the row I and the column is X. So if this doesn't match the current cell in the previous worksheet, and the current cell again is the value in row J, and the column is again X. Then, and close the if. So now that we have found a mismatch, we need to note this down in the first available row in the change worksheet, which is the last row plus 1. So let's find the first available row, which is this one, which is the last row using the current regions.rows.count. And to find the available row, add 1. And now we can start populating the values in these columns. In the first column of the change worksheet, we will fill in the item ID. So how do we reference the current cell in the change worksheet? Well, we have to give the row index and the column index. The row index is this last row variable, and the column index is 1 because we'll be in column A. And we're filling in the item ID out here, which is just this. Okay, so we're going to fill in 3 more columns. I'm just going to paste this in 3 times, and we'll change the values as we go on. So here we filled in the value in column A. Next, we need to fill in the value in column B, which is column 2, column C, which is column 3, column D, which is column 4. And now we can change what value we need to be assigning all of them. So in the second column, we will fill in the column field so that we know which field value is changing. So suppose in this case, the unit weight is changing for this product code. And in column B in the change worksheet, we want to fill in the value unit weight, which is in the first row of the current column. So the first row is row 1 and the current column is X. The third column is the previous value. And what is the previous value? Well, it is the value that we are checking on, which is this one right here. And the fourth column is the current value, which is this one right here. And once we found a match in the previous worksheet, we don't want to continue looping over the rest of the previous data set. So we will jump to the next item ID using a line label. So after this loop is complete, we can jump to the next item ID. So we'll place in a line label, and we'll assign the line label just before we are about to jump to the next item, which is right down here. And if you have finished looping over the entire previous data set without finding a match, then it means that the item ID does not exist in the previous data. So it's obviously new, and we should add it to the new worksheet. Let's find the next available row in the new worksheet. This is the same as what we did up here. And this time around, we're just filling in the item ID. So the row index will be the next available row, which is this one here. And we're filling it in column A, which is column 1. And what are we filling in? We are filling in the item ID. Okay, that's almost the full code. Let's test this out before we continue further. Come up here and hit run. Let's come to our change worksheet. We can see the values that have changed, and come to our new worksheet. we can see the values that have been newly added. We need to find the deleted lines as well. For this, we need to do the opposite of what we've just done above out here. That is, now we will compare the previous data versus the current data. Let's declare a variable to hold the last row in the deleted worksheet. Now we can write the whole loop again, or just copy everything from top here. Note, we'll just be copying the first and the second loop. We're not interested in this inner loop because this just determines what has changed, and we've already found that out. I'm gonna just go ahead and copy because I'm lazy and I would rather copy and paste wherever I can. So copy this whole part out, paste it below, copy this part at the bottom, paste it below out here. First, let's change this line label, call it line next to, line next to. And now, as I said before, we're gonna do the exact opposite. So wherever we see current, you will change it to previous. And wherever we see PREV, we're going to change it to current, which basically means the outer loop will be on the previous worksheet and the inner loop will be on the current worksheet. So that's done for the loop. And for the final change, here we're placing the unmatched item ID in the new worksheet. We need to update this to place the item ID in the deleted worksheet. So a quick way to replace new with del would be just highlight these two rows, go Control F, search for new, hit replace, replace with del, make sure that the selected text has been selected, hit replace all, click OK, close this, and you can see that the values have been updated to del. Awesome. This is our code. Let's save this and run the macro. That's run, come to our worksheet, and the deleted worksheet has been populated. Says 120067 has been deleted, which is this red row out here, which is correct. Awesome. Let's move on to the next section. So in this section, we're going to use Range.Find instead of this inner loop. Let's create a new module, give the module name. Let's create a new sub. Actually, what we'll do is come back to our previous sub and just copy it over. We'll rename the sub to 2. So basically the structure of the macro kind of remains the same. We'll just be updating our code out here to fit in the range.method. Okay, we'll talk through this as we move through the code. We'll be searching for item IDs in the first column of the previous data. So let's declare and assign a range to hold the first column of the data in the previous worksheet. So declare a range variable. Let's set this. So how do we find the first column of the data set? We will first determine the current region and then grab the first column. So we've already seen how to grab the current region. So what we'll do now is access the columns object and provide the index number for the first column, which is column 1. And that's it. The find method will return back a range. So let's declare a range variable to hold the results. And once we find a match, we need to determine the row number of that cell. So let's declare a variable to hold that row. Let's come to our loop now. We're going to shift the sequence of the previous macro slightly. In the previous macro, we first search for a match in the inner loop. And if no match is found, we will assume that it's a new item. This time, we will search for the item directly using find method. If no match is found, we will assume it to be new, log it in the new worksheet, and then proceed to the next item. But if a match is found, we will log it in the change worksheet. So in short, what we're going to do is first check for a new item. And if it's not new, then we'll check for any changes. We won't be looping over the previous worksheet anymore. So delete all of this off. First, we'll search for new items. As per our declarations, we are going to hold the search results in this variable. Next, we need to say where we're going to check. We need to provide the range in which we're going to run our check. The range is the first column in the previous worksheet. And we'll invoke the find method. Let's take this into a next row. So underscore enter. We'll specify what we're looking for, which is the current item ID. Next row, what are we looking at? We're looking at the entire cell value. So if this search result returns nothing, then this range variable will not be populated and its value will be nothing. So if this is nothing, we will find the next available row in the new worksheet and populate the first column in that row with the current item ID. In fact, we can just cut this, paste it below, tab this out. And if that item ID does not exist in the previous worksheet, then we can basically just jump on to the next item ID in the current worksheet. So we'll just cut this reference to the line label and paste it here. But if a match is found and this range variable is populated, then we need to determine which row we found the result in. So the row variable where we're going to hold this result is this one right here. And it is going to equal to the row of the range where we found the result. And since we're going to continue this loop multiple times, let's set this variable to nothing once we're done with it. So here we're determining whether the item is new or not. And if we find a result, then we need to search for changes in the columns, which is basically this code right out here. So let's clean this up slightly, delete off the rows and just align them back. And that's it for the top loop. And for finding the deleted lines, we're going to use the same logic, that is, do the exact opposite. So just to recap, we're going to loop over the previous data set, search whether every item ID in the previous data set exists in the current data set. And if it doesn't, we will assume that that item has been deleted. So similar to what we did out here, let's declare a range variable to hold the first column in the current data set. Update this to current. Delete off the inner loop. Now we're going to use the same search logic. Copy this part. This time we're searching in the current worksheet and we're searching for the previous item ID. And if the search result returns nothing, then we'll update the deleted worksheet, which is this code right here. And if a match is found, well, we're not going to do anything about it. We will just set the range found variable to nothing. Okay, let's save this and run the macro and we get an error. Let's hit debug and see where the error is. So we need to update these rows. What this error is saying is that it cannot find a reference to row J, which is obviously true because we're not running an inner loop on the previous worksheet anymore. So column J actually makes no sense. We need to think what is the replacement value for the current row where we found a match in the previous worksheet. Well, it is this item row. So what we need to do is copy this and replace the J with item row. And I can see now the J out here. So this will throw an error as well. Delete this and replace it with item row. Finding errors is always good. It helps us understand our code better. So let's stop this and run the macro again. Okay, it's run. Come back to Excel. The change worksheet has been populated. 3 new items have been added new and 1 item has been deleted. So the macro is working fine. Awesome. Now let's replace this Range.Find method with dictionaries. This would be my preferred way of conducting this operation. Let's create a new module. Give it a name. We will copy the previous sub-procedure and paste it here. We'll update the sub-procedure name. If you're familiar with dictionaries, then this part would be rather straightforward. And by that, I'm referring to the fact that the structure of the loops will remain the same. We will just replace the find part with dictionaries. We will keep the item row, but we'll delete these ranges off. Let's create a dictionary. Our dictionary will have a key and a value. Let's create variables to hold each of them. So what are we going to put in this dictionary? We're going to loop over the previous data set and feed in the item ID as the key and assign the value as the row number where that item ID is placed in. Let's loop over our previous data set. The key will be the value of the cell in the current row in the first column, which is column A, and the value will be the current row. Now let's add this key to the dictionary and assign it a value. So to add the key, we just go the dictionary name, the key variable, and let's add the value. And just notice one thing, we're going to be using I before we're declaring it. So this will throw an error. So let's cut this out and declare the I variable before we actually start using it. Okay, so that part was for creating the dictionary. Let's come to our loop. Okay, so first let's delete out the search method. So what are we doing out here? We are checking whether each item ID in the current worksheet exists in the dictionary that we have created out of the item IDs from the previous worksheet. And if it doesn't, then that means that that item ID in the current worksheet is a new item ID. And how do we check that? We will use the exists method of the dictionary object. So if it doesn't exist, then, so we are basically replacing this if statement. And if no match was found, then we populate the item ID in the next available row of the new worksheet. So all of this will remain intact. But if it does exist, then we want to be able to jump to that exact row in the previous worksheet. How do we get the row of the previous item ID? We'll just grab its value using the current item ID as key. And we don't need this part. And that's it for this loop. Coming down to a deleted lines part, we need to create a new dictionary that will hold the item IDs in the current worksheet. And then we will loop over the item IDs in the previous worksheet and check whether each exists in that dictionary. So let's copy this part. This range part belongs to the find method. We don't need this. We'll call the dictionary dig cur for current. We don't need to assign these again. And just as we have done before, update all the prev with cur. And as we did in the above loop, we can delete out this part and just check whether the previous item ID exists in the dictionary of the current item IDs. And we can delete out these lines. And actually we don't need the line labels either. Let's save this. And that is the code for the dictionary. Let's run and see if this works. Okay, that ran. Deleted worksheet has populated. So has the new worksheet and the 3 rows for all the changes. Awesome. That's worked. Now moving on to a dynamic code. Okay, now for the magic trick that will make this code fully dynamic. We're just going to update the code from the first section. I will leave it to you to update the rest of the sections since it's based on the exact same logic. We are performing comparisons on the item ID column, which is column 1. In all our code, this is the only column number which is hard coded. And you can see that out here, we are hard coding the value 1, which stands for column A. For the 2 data sets, we are determining the last rows and the last columns using current region, which is dynamic. That is, it'll adjust based on the size of the data. So no issues there. All we really need to do is address the hard coding of this column ID of the lookup column. So let's declare a constant for this at the top. We'll call it compare ID. It's holding a column number, so it can be a long. And for our item master data set, the item IDs are in column 1. So we'll assign this constant the value of 1 as well. Now we need to make few modifications to our code. Here the item IDs in our current data set are numbers, so we have declared them as long. But if you want to make this dynamic, the lookup columns could be either text or numbers. So we need to account for both. And the best way to do that is declare both as variants. So let's do that. There's no S in variants. Now let's replace these hard-coded value with this compare ID constant. And for the deleted lines as well. And for the very final change, when we're looping across the columns, we're ignoring column 1 and jumping straight to 2 because that's where the lookup column was. But in a dynamic context, the lookup column can be in any column, say the second or the third column. So what we will do is just loop over all the columns. So change 2 to 1 and that's it. Now code is dynamic. Let's test this first on our existing data set. Actually, what I'm going to do is that since I'm going to be uploading this file to GitHub, we will save this dynamic code as a separate sub procedure in a different module. So let's create a new module, give it a name, and let's just copy this over. And later on, I will just revert back this first macro back to its original state. Let's go to the dynamic module, call this macro 4, save the file, and let's run the macro. Okay, that ran. Awesome, no surprises there. And for the real litmus test, let's change our data set. So I have a couple of new data sets out here, one with old grades and one with new grades. Okay, so now we have old grades in the previous worksheet and the current grades in the current worksheet. Okay, so now let's come back to our dynamic macro. We've updated the data sets, but what we need to do now is we need to update which column we're going to run a lookup on. In the previous data, we were looking up on the first column. In this data, we're going to look up in the third column, which has the student IDs. So we will update this to 3 and run the macro. Come to a change worksheet, looks good, new, deleted, awesome. So all of that seems to be working, and that was the final of all our macros. Next, let's briefly look at what else can we do with this same logic. So we can modify this further. For example, if I had to do this, I would put both data sets into dynamic arrays and loop over the arrays instead of looping over the physical ranges. This would save a lot of time as the data set grows bigger. Also, you don't need to restrict this code to doing hard comparisons. Let me explain. In my experience, we would allow users to make changes to the item master data as long as they are within a predefined threshold. For example, price changes may be allowed within the range of say plus minus 10%. So we can modify our code to control for that. That is, first check whether an item attribute has changed and then check whether the change is within the approved threshold or not. And that's the video. It might have been a bit of a brain puzzle, but through practice, this could become a very useful piece of code in your arsenal. And the dictionary version will work reliably across large data sets with hundreds of thousands of rows and hundreds of columns. But there can be many more ways of achieving the same result. If you do something similar using different techniques, I would love to know in the comments below. And if this video was useful, please do like and subscribe. Thanks, and see you in the next one.